So for number 1, you're asked to find out what value of what angle measure, right, between 0 and 2 pi is your x coordinate 1/2, right? Or at what angle measure is your cosine ratio 1/2? So you're given the ratio and you have to figure out the angle. If you look at your unit circle, right, x coordinate is positive in quadrants 1 and 4, so where is that going to be? Pi over 3 and 5 pi over 3. Are you guys okay with that? Okay, so those are your answers. Notice how before I would give you the angle measure and you'd have to tell me the ratio, right? What's the cosine ratio of pi over 3? And you'd look at the x coordinate, right, at cosine. And you'd be like, oh, it's 1/2. Or what's the cosine of, oh, I'm sorry, it's frozen. Okay. What's the cosine of 5 pi over 3? And you tell me 1/2. Remember, that's how you would do it, but we're going backwards. You're going to be given the ratio, and you have to tell me the angle at which the ratio applies. Yes?
And it's in radians?
It's in radians because it says theta is between 0 and 2 pi, and those angles are in radians. Okay. Yeah? All right, number 2, it says, where is your sine ratio negative root 2 over 2? At which angles? So your y coordinate, right, where is it negative 2 over 2? It's the bottom 2 quadrants. What 2 angles are they? 5 pi over 4 and 7 pi over 4. Good. You guys see that? The sine of 5 pi over 4 is negative root 2 over 2. The sine of 7 pi over 4 is negative root 2 over 2. Do you see how if I hadn't restricted the angle to be between 0 and 2 pi, there's actually an infinite number of possibilities? Because there's all these coterminal angles, right, where you can add or subtract revolutions. Do you see what I mean? Like if I did like 5 pi over 4, if I added like another 360 or 8 pi over 4, like 13 pi over 4, right, would also give you the same answer. Sine of 13 pi over 4 is also negative root 2 over 2. Nod your head if this makes sense. There's an infinite number of possibilities. Okay, tangent theta equals root 3. That means what angle is your y over x equal to positive root 3 from 0 to 2 pi? Where is y over x equal to the positive root 3? Where is it? Pi over 3. You're looking at your unit circle, you're looking at y over x, and in quadrant 3, because it's negative over negative, giving you a positive, 4 pi over 3. Raise your hand if you actually got all 3 of them correct. Yeah? Okay, nice, very nice. Okay. Questions? Yes, Mason?
In one point I'm in radians now.
Yeah, because so in algebra 2, I would ask you, find it between 0 and 360, right? But here it's asking you to find between 0 and 2 pi, so you want to make sure you're in the right units there. Okay? So again, that's going to be a big difference in terms of what you did in algebra 2, because we did do this in algebra 2. And pre-calc is that we're going to deal more with like radians. Yes? All right, so let's take a look at the following. Okay, if I have cosine theta, and I tell you that it's equal to 1/2, you just thought backwards, right? Oh, where is your x coordinate equal to 1/2 or your cosine ratio equal to 1/2? How could I undo that cosine if I wanted to get theta by itself? I don't divide by cosine, by the way. I'm not going to multiply. What's the inverse of cosine? Just inverse cosine. Okay, so the reciprocal of cosine is secant, but the inverse of cosine is just inverse cosine. So these cancel out. You get theta is equal to inverse cosine of 1/2. So this is what you're going to be shown. You're going to be asked, what's the inverse cosine of 1/2? And then you have to figure out the angle measure at which point that's true. Okay? But remember, we said there's an infinite number of possible angles that would make cosine ratio 1/2, right? There's an infinite number of them, like pi over 3 and 5 pi over 3 and all the coterminal angles. And this is a problem because we're dealing with inverse trig functions. And remember, for functions, for every input, there is how many outputs? For every input, there is one output. Do you guys remember this? Yes? Okay. All right. So you can just say stuff. If you get it wrong, not a big deal, right? So for every input, there's exactly one output. And that's a problem because here, for the input of the ratio of 1/2, there's an infinite number of possible angles. So there's going to be some restrictions that are implied. Okay, so implied restrictions for inverse trig functions. So there are some implied angle restrictions that are placed so that you would only have one output, or you would only get out one answer that's an angle measure for the input of the trig ratio that you have. So I'm going to just tell you what it is first, and then I'll explain why. So let's say I have cosine theta is equal to some ratio. Okay? Again, we can take the inverse cosine of both sides, and you get theta is equal to the inverse cosine of that ratio. So you're given the inverse cosine, and you have to come up with the answer. Inverse cosine could also be written as arc cosine. Okay, so inverse cosine and arc cosine are the same, just two different ways of writing it. Have you guys seen arc cosine before? Yeah, some of you? No? Okay. So, and here are the restrictions. So for inverse cosine or arc cosine, if you see that, then you know that this angle here needs to be between 0 radians and pi radians. Okay, 0 radian and pi radians. Another restriction is that, see this ratio right here? Okay, that ratio needs to be between -1 and 1. Okay, so these are the restrictions we need to remember. So here's the part you need to remember, and I'm going to explain to you why that is. So you don't have to draw this graph, it's just a y equals cosine graph. I'm going to explain it to you why this is true. Okay, so look at the cosine graph, right? So that's y equals cosine graph, but cosine theta, but we are going to do the inverse cosine. So this is a function because it passes a vertical line test, right? But we're interested in the inverse. Does it pass the horizontal line test? No, it doesn't pass the horizontal line test because it, right? See, like the horizontal line, it connects at more than one location, so it's not okay. So what they did is, they, meaning whoever like came up with this agreement or this definition that everybody uses, is they restricted the region to be between 0 and pi. Okay, so if you look from 0 to pi, does that portion of the graph right here, does this portion of the graph, does that pass the horizontal line test? Yes. So we know that the inverse cosine is going to be an actual function. We have an inverse cosine function. Yes. So it's been restricted. So your angle, right, that you get out, if you're asked to find the inverse cosine or arc cosine, it has to be between 0 and pi. Questions so far? Okay, let's take a look at an example. If I ask you, what is the inverse cosine of 1 over 2? What is the inverse cosine of 1 over 2? Okay, inverse cosine of 1 over 2. So what this is asking you is if cosine of theta is equal to 1 over 2, where theta is between what two angle measures? If it's inverse, it has to be between 0 and pi. What would it be? Do you guys see that? That's how you would interpret it in your head. So you look at your unit circle, you're only looking at quadrant 1 and quadrant 2, where your x-coordinate would be positive 1/2. And where is that? Where is that? Pi over 3. Okay. So pi over 3 is your only answer, because you could only get an answer between 0 and pi by definition. Okay, so if you see this here, by definition, it means, right, the inverse, right, means you can only get out one answer, and it has to be between 0 and pi. Everybody show me with your arms, go like this, okay? 0 to pi. Like, go from this way to here, right, like this way. Because this is 0, yeah, there you go, 0 to pi, okay? This way first, from 0 to pi, right, from your view, this should be 0 to pi, okay? Okay, let's take a look at the next one. We're going to take a look at the sine function. So here's sine theta is equal to, right, some output, like some ratio. sine of the angle theta gives you a ratio, right, opposite over hypotenuse, or y over r. Again, if we are undoing that, if we take the inverse sine of both sides, then we get theta is equal to inverse sine of the ratio. So it would ask, you would have to like find the theta given the ratio here, right? Arc cosine was another way of writing inverse cosine. So what would be another way of writing inverse sine? Arc sine, right? So arc sine, you might see it get written this way, arc sine. Okay, let me go ahead and tell you the restrictions first, and then I'll explain where that comes from. So you see this angle theta, your answer, it has to be between, by definition, negative pi over 2 and pi over 2. Okay, we'll look at this, what it means, and explain it. And then see this number here, the ratio. That ratio has to be between negative 1 and 1. Okay. Oh, I forgot to explain that for cosine. We'll go back and look at it. Okay, so here we go. Okay, so here's a sine graph. Here's a sine graph. So just a regular y equals sine theta graph. So normally, like, we graph this portion here, right? But does that part, like, pass the horizontal line test? Nope, it doesn't. So what about like 0 to pi? Does that pass the horizontal line test? Nope, it still doesn't. So what they did is they selected a region where it would pass the horizontal line test. And the region that's selected is going to be between negative pi over 2 and pi over 2. So this little portion right here, that part of the graph, is going to be for your inverse sine. So they restricted it so that we actually have a function, right? And not like one with like an infinite number of possibilities. Okay, in terms of the ratio, take a look at the ratio here. And it was the same for the cosine as well. See the ratio? See how the graph is between negative 1 and 1? Yeah? So your ratio needs to be between negative 1 and 1. Makes sense in terms of the unit circle too, right? Your values, right? Your y coordinates are always between negative 1 and 1, right? Same thing for cosine. Yes? Okay. So, yes, question.
So for a sine, we just need to put it between negative 1 pi and positive 1.
Needs to be between negative pi over 2 and positive pi over 2, right? So your ratio needs to be between negative 1 and 1. Right now we're focusing on the angle. Your angle has to be between negative pi over 2 and pi over 2. So the way I want you to think about this is as follows. So here's your 0. You're going to go to negative pi over 2. Do you guys see that? So that's in quadrant 4, but you have to go in the negative direction. And then you're going to go to positive pi over 2. You guys see that? So our answers are in quadrant 1 and 4, but normally you go like that, right? You go like that in the positive direction, but we have to go in the negative direction for our quadrant 4 answer. So with your arms, show me standard position, 0, right? Your answers are going to be from 0 to pi over 2, or 0 to negative pi over 2. So like this, yes? Like this, not like that, yeah? It's like this. Okay, so let's take a look at an example. Example. If I asked you to find the inverse sine of root 2 over 2. The inverse sine of root 2 over 2. Okay, so again, what you're thinking is in your head, right? You're given a ratio of root 2 over 2, so you're thinking in your head, sine theta equals root 2 over 2, but I need to figure out where that's true, where the angle theta is between negative pi over 2 and pi over 2, right? But you think like 0 to pi over 2 and 0 to negative pi over 2. So where is that true? Is that going to be quadrant 1 or quadrant 4? Quadrant 1, because your sine, your y coordinate's positive in quadrant 1, and it's going to be at pi over 4. Okay, so let me go ahead and show you the second example where it's a little bit trickier. So here's the second one. What if I asked you to find the inverse sine of negative root 2 over 2? Okay, so again, we're looking at quadrant 1 and quadrant 4. But if you look at quadrant 4 on your unit circle, you might think that it's what? You might think that it's 7 pi over 4. Do you guys see that? But that can't be the answer, because is 7 pi over 4 between negative pi over 2 and pi over 2? No, 7 pi over 4 is more than pi over 2, right? So it doesn't work. Do you guys see that? So instead of going like in the positive rotation all the way, because it's excluded, we have to go to 7 pi over 4 in the negative direction. How much is that? Negative pi over 4. So your answer is negative pi over 4. Okay, think about it. Sine of negative pi over 4, that's the same thing as sine of 7 pi over 4, which is negative root 2 over 2. Do you guys see that? So you have to give your angle within the restriction, right? It has to be, if it's in quadrant 4, you have to go from 0 to negative pi over 2. I'm going to have you talk to your neighbors about this real quick. Make sure you guys understand what's happening. So I just wanted to explain. If you do negative root 2 over 2 on the calculator, it gives you about negative 0.7. Okay, so if you look at the graph, you would see negative 0.7 is about like here. And so normally you'd go over here and you'd be like, hold on, negative root 2 over 2. Negative 0.7. Okay, and so you'd look for that answer, which is in quadrant 3, but because we're looking for an answer in quadrant 4, you'd go here, which was like 7 pi over 4. Do you guys see that? But we need our answer to be between this region here, so we need this value right here, yeah? And that angle is negative pi over 4. So Nick kind of summarized it. The way he's thinking of it is, if you have an answer in quadrant 4, you just go in the negative direction. So it's going to be like negative pi over 6, negative pi over 4, and negative pi over 3. Do you guys see that? If you get an answer that's 5 pi over 3, then you need to say it as negative pi over 3. If you get an answer that's 7 pi over 4, you need to say that as negative pi over 4, right? The coterminal angle. If you get 11 pi over 6, then you need to say negative pi over 6 so that it's in the right region. Yes? You guys okay? Or let's take a look at the tangent one. Last one. Tangent one. So if I have tangent of theta is equal to some ratio, again, if we take the inverse tangent of both sides, okay, these cancel out, you get theta is equal to inverse tangent of some ratio. Okay, so again, instead of giving an angle and asking you to find the tangent ratio or the tangent function of that, you're given the answer and you have to get out the angle measure at which this is true. What's another way of writing inverse tangent? Arctangent, right? Arctangent of the ratio. Okay, so here are the restrictions for this angle theta. The theta has to be between negative pi over 2 and pi over 2, but notice that it's not included, right? So it's not like greater than or equal to, it's just greater than and less than, yeah? And then your ratio that you have here, it can be all real numbers, so it's between negative infinity and infinity. Okay, and I'll again explain what this means using this graph here. Okay. So here's a graph of the parent function y equals tangent theta. Does it pass the horizontal line test?
Yeah.
Yes. So we are going from negative pi over 2 to pi over 2. But what happens at negative pi over 2 and at x equals pi over 2? What happens there? What do you have? Asymptotes. Do you see how you have asymptotes here? It's because it's undefined. That's why it's not included here, right? It's just exclusive of those endpoints because you don't actually have any points on those ends. Okay, and then let's take a look at the ratios that you can get out. What types of ratios? Remember, for sine and cosine, they were bound between negative 1 and 1, but what happens for the tangent graph? It's all real numbers. See how it extends forever in both the negative and the positive direction? Yes, so your ratio is not limited. Okay, let's take a look.
Maybe it's not limited. Oh, so
It doesn't have to be between negative 1 and 1. It could be any number. Okay. And we'll take a look at some examples to explain what it means. All right, example. Find the inverse tangent of root 3. The inverse tangent of negative root 3. And the inverse tangent of 0. Okay. Again, for that first one, you're thinking, what is tangent theta equal to, at what angle theta is tangent equal to positive root 3, such that your angles are between negative pi over 2 and pi over 2. Okay. I'm going to give you a little bit of time to try these 3 problems. Okay, let's go ahead and take a look at this. For the first one, it's asking you, where is your y over x equal to root 3? And for inverse tangent, you're only looking at quadrant 1 and quadrant 4, right? But remember, for quadrant 4, you have to go in the negative rotation because it's to negative pi over 2. So where is your y over x equal to positive root 3 in these quadrants, right? Remember, at pi over 3, root 3 over 1. Right? That's going to be the answer. So pi over 3 is the correct answer for number 1. For number 2, for y over x to be negative, we know it's going to be in quadrant 4, right? In quadrant 4, and then at 5 pi over 3, we see that negative root 3 over 1 gives you negative root 3. However, we can't say 5 pi over 3 because 5 pi over 3 actually goes all the way around like that, right? Remember, for inverse tangent, it has to be between, right, negative pi over 2 to pi over 2, meaning 0 to negative pi over 2 and 0 to pi over 2. So 5 pi over 3, we have to rewrite it as negative pi over 3, right? Because that's negative pi over 3 going that way. Yes, remember, negative pi over 3, negative pi over 4, negative pi over 6, those are the types of answers you're going to get. It's a coterminal angle, right? Coterminal angle. So if you want to, you could subtract 6 pi over 3 from 5 pi over 3, or just think you're going negative pi over 3. All right, for number 3, the tangent, inverse tangent of 0. So the ratio is 0, so that means y over x needs to equal 0. The only spots we see 0 are at pi over 2, 0, and negative pi over 2. Well, pi over 2 and negative pi over 2 are actually not even part of your restriction, right? So you can toss that up. But even if you didn't know that, if you did 1 over 0 or negative 1 over 0, what do you get? Undefined, so that's not going to be it. It's at 0 that y over x, right? Y over x gives you 0, so the answer is 0 radians, right? Tangent of 0 is 0. Okay, I'm going to give you a 5-minute break here, and then we'll continue.